The following presentation will focus on the methods used to collect water quality data. Water quality is considered a contingent method within the lentic aim protocol, meaning that these methods are only applied where certain conditions exist. This is the case for water quality because many wetland and riparian areas have intermittent or seasonal hydrology and lack surface water throughout much of the growing season. To follow along, you can refer to section 7.2 of the 2021 lentic aim draft protocol, which is found on page 119. If sufficient surface water or groundwater is present within the monitoring plot, water quality data should be collected. These measurements should be made before any other data are collected in order to minimize sediment disturbance, which can affect measured values. Additionally, collecting water quality data early in the day will limit the impact of diurnal changes in water quality due to temperature fluctuations and metabolic activity of organisms in the water. For the purposes of the lentic aim program, we collect pH, conductivity, temperature, and a nutrient sample. To collect water quality information, you will need a multi-parameter water quality probe, such as a YSI, calibration fluid and deionized water, nitrile gloves, a sample vial, a cooler, preferably packed with dry ice for freezing nutrient samples, write in the rain labels, packing tape, and a long-handled dipper cup, which is optional. At sample plots with sufficient surface or groundwater, we collect pH, conductivity, and temperature. pH is a measurement of hydrogen ions in a solution. The more hydrogen ions, the more acidic the solution, and the less hydrogen ions, the more basic the solution. Runoff from activities such as mining can result in lower pH values. Conductivity measures the capacity of water to conduct an electrical charge, which increases with the concentration of ions in a solution. Conductivity is commonly correlated with a degree of salinization. Activities such as irrigation runoff and return flows can increase conductivity levels. Water temperature can have a direct influence on the diversity and distribution of organisms within a body of water. Water temperature data should always be recorded on the Celsius scale. Measurements of pH, conductivity, and temperature can all be collected using a YSI sonde or similar multi-parameter water quality probe. These measurements can be taken from multiple locations within the monitoring plot, including within the soil pit, within flowing channels, and in standing or sluggish surface water. The component of the YSI sonde circled in red is referred to as the probe. Multiple sensors exist on various locations of the probe. The water depth at each measurement location must be deep enough to submerge the entire probe. If water is not deep enough to cover the entire probe, water quality measurements should not be taken at that location. When collecting data at a water quality location, be sure to allow enough time for readings to stabilize before recording them. This can sometimes take several minutes. Throughout the field season, it is important to maintain your YSI sonde. They are expensive pieces of field equipment that are relatively delicate. It is critical that each YSI is calibrated at a minimum of every 7 days to maintain accuracy. If a YSI being used to collect water chemistry data has not been calibrated in the past 7 days, data will not be considered valid. Additionally, if the YSI values are atypical, it is essential you recalibrate the machine. If there is explainable reasoning for the unexpected value, please include comments. One instance would be a low pH value of 5.5, but there is obvious evidence of mining runoff just outside of the monitoring plot. High conductivity values are often observed in hypersaline wetlands, such as salt marshes, but are not expected in freshwater systems. Additionally, it is important to protect your YSI SON from excessive sun exposure, rain, and always avoid exposing the machine to any liquid, including water and calibration fluid. Water can easily damage the battery ports of the machine and render it unusable. Additionally, it is recommended to regularly clean the sensors on the probe. In addition to in situ water chemistry information, a water sample, or grab sample, is collected on a single location within the monitoring plot. Water quality samples will be sent out for laboratory analysis for total nitrogen and total phosphorus at the end of the field season. Nutrients, such as nitrogen and phosphorus, are essential for plant and animal growth. However, high concentrations of nitrogen and phosphorus can have detrimental effects on the environment. Soil erosion, agricultural runoff, and excessive manure can all contribute to high concentrations of nutrients. One historic example of the effects of nutrient loading on an ecosystem would be the toxic algal blooms on Lake Erie. When collecting a nutrient grab sample, it is important to use clean gloves to avoid contaminating the sample. The location of where a grab sample is collected will vary on a site-by-site basis. A grab sample needs to be collected in an area of open water that is deep enough to prevent disturbance of the bottom sediments during collection. Ideally, this location should also be away from any inlets and outlets, towards the middle of a water body, and close to plot center. This concludes the Water Quality Methods video. For more information about water quality methods used in the Lentic AIM program, consult Section 7.2 of the Lentic AIM 2021 Draft Field Manual.